Hello friends, welcome to Dr. Ossai Physiology Academy, DOPA for short. This is the place where we make the learning of physiology easy, exciting, and effective. Thank you for joining me. So if you are new to this channel, you're especially welcome. Just help us click the like button, the subscribe button, and don't forget to turn on the notifications if you enjoy the content that we share. Let's grow the channel together. All right, so now let's go to the part 3 of the gastrointestinal motility. So intestinal motility, it's very easy to understand, okay? Very easy. We dealt with the gastric motility, how there is this mixing, okay? Mixing, churning the food, and then the emptying. So here, this intestinal motility also has that mixing function, but the purpose is different. In the stomach, the purpose of the mixing is to really break the food. Okay, so that's why that ending part of the stomach has very thick, smooth muscle. Okay, but the intestines, they are very slender. Okay, especially the small intestines. So this intestinal motility is divided into two: small intestinal motility and large intestinal motility. So let's start from the small one. Now, both of them have similar properties, but some differences also. So one of the motility functions of the small intestine is what we call segmentation. Segmentation. What do we mean by segmentation? Now, it is called segmentation because of the form and the shape that it changes the small intestine into. Now, watch this. You see something like this. Although not as big as this, okay? But something like this. So what happens is that there are intervals of contraction. There's contraction. There's relaxation. Continuously like that. So it turns the small intestine into like a chain of beads, the shape of beads, or some call it a chain of sausages. Okay? So there are intervals of contraction. So what happens is that it is not static. This part that is contracted later relaxes, and this part that is relaxed later contracts, and it continues like that. Continues. And what happens is that it leads to a lot of mixing. Okay? So it's a mixing contraction and movement, this segmentation. It chops it into small pieces, the food, different segments like that. And the purpose is to mix the enzymes, digestive enzymes. Remember, whenever food enters the small intestine, there are two responses: contraction of muscle and release and secretion of enzymes, electrolytes, water, fluid, secretion. Okay, so that mixing is to enable digestion, because the small intestine is the domain of digestion and absorption. Okay, so the purpose of this is to enable mixing of chyme with digestive juices, okay, to now enable digestion and absorption. All right? So that's what happens. Segmentation. Then there is another form of motility in the small intestine. It's called peristalsis. We usually call it propulsive movement. Okay? Propulsive. So the purpose of this type of movement is to push the food, the chyme, this time call it chyme, push the chyme forward. Okay? So from the duodenum, which is very, very short, the shortest part of the small intestine, it moves to the jejunum. That's where a lot of digestion and absorption takes place. The jejunum and the ileum together are almost 6 meters long. Okay? So it pushes it till it goes. But this movement generally is slow. Why? Because there needs to be enormous time to allow for digestion and absorption. Okay? So generally, think about 3 to 5 hours. The food transits that 6 meters. Okay? So that's what happens. So although some sources, some authorities, they usually say that these two it's not easy to distinguish them, because sometimes this segmentation contraction, there's some propulsive movement, but not very pronounced. Okay? So, but to be simplistic, we just take it that the segmentation reaction does not move the food, just stationary, static. So don't get confused. Sometimes you might read some sources and they tell you that it's static. Some other times they'll tell you that it still moves it a little. Okay? So that's just what happened. Majorly circular smooth muscle, from their shape. They're very powerful muscles. They're more powerful than the longitudinal smooth one, which does more of the propulsive movement. Okay? So these two movements, they occur. But there's another kind of movement that occurs. It's called peristaltic rush. Remember that I said that this peristalsis is not so fast. It takes about 5 hours to go through the length of the intestine. But peristaltic rush, from the word rush, is already telling you something, that it pushes away the food, powerful, because the normal longitudinal smooth muscle does not push it so fast. But when there is a problem, especially when there is irritation, okay, it can be maybe from infection, it can be even from the food. It maybe sometimes very spicy foods. You might have experienced it. You take very spicy food. Sometimes people who take suya, it affects some people like that, very spicy. So it irritates the wall of the small intestine and it causes this type of peristaltic movement, rush. It hastens the movement because it wants to flush out that irritation. So it's a propulsive movement, peristalsis, but it's faster and more powerful. All right? So this is what happens. So there's a fourth one. It's another fourth kind of movement of the small intestine. We call it movement of the villi. Okay? You have villi, intestinal villi, those folds with the finger-like projections. And those ones also have another finger-like projections called microvilli. Okay? So the microvilli, that is where absorption takes place. So this movement of the villi aids absorption, and it is carried out by what? The muscularis mucosa. Muscularis mucosa. Remember in the previous lecture, introductory lecture when we're talking about the layers, that the mucosa has a muscularis mucosa, lamina propria, then epithelium. Okay, so this muscularis mucosa within those villi, they contract. So they help in absorption, they favor absorption. So that is the purpose of this. So each and every one of these 4 types of movement by the small intestine, always think about the purpose. It will make you remember segmentation is for mixing, to enable digestion. This one is to enable movement, to move it to the next part of the small intestine. You have finished your digestion. Okay, now go forward to the large intestine. So the undigested one can be removed. Okay, that's the purpose of this one. Then this one is for offending agents, irritating agents. Push it out fast. Then this one is to aid absorption. When after digestion, there needs to be absorption. Okay, so that is what you need to understand about this. But before we go to the large intestine, there is something that 2 major scientists, I think in the late 19th century, early 20th century, Bayliss and Stalin, they studied the intestine a lot, and they discovered a law which we usually call the Stalin law of the intestine. Okay? Stalin law of the intestine. Okay? The law is very easy to understand. It's just talking about the fact that whenever there is distension of a segment of intestine, obviously because of food, that the part of the intestine that is proximal to it, that's before it, usually contracts, while the part after that bolus of food usually relaxes. Okay, that's just what you need to know. Okay, the proximal part, proximal to food, contracts. Distal to food relaxes. Okay, and by so doing, it enables the movement of food. So just put that at the back of your mind. So we're now going to talk about the large intestinal motility after this break. Welcome back. So now I want to focus on the large intestines. Okay? So they are similar, but like I said, there are some important differences. So this one, number 1 movement, is divided into 2 major kinds of movement, motility of the large intestine. One is the same segmentation. Okay? Segmentation. Okay, so in this segmentation contraction, the large intestine is very thick. Okay, it has a thick outer serosa and all of that. So but along the line, there's, just for your knowledge, I know you know from anatomy, you know that there's the longitudinal muscle is prominent and it forms what they call tinea coli. Okay, so this is just trying to tell you why this segmentation reaction is called a special name. It's called hostrations. Segmentation contractions called hostrations because of the shape. Okay, this is how the large intestine looks. Okay, pardon my drawing. So this is the tinea coli. All right, so it's similar. It divides it into segments: contracted area relaxed, contracted like that. So this segmentation reaction is also for mixing. But what is the purpose? While in the small intestine, the mixing is to aid digestion, mix it with digestive juices. For the large intestine, digestion does not happen. Okay? So what is the purpose of the mixing? Is to enable absorption. Right? So the purpose of this segmentation is to enable absorption of fluids and electrolytes. Because about 10 liters of fluid generally are secreted into the small intestine. But at the same time, a lot of them are absorbed. Okay? So about 600 mils are still left when it enters the large intestine. Okay? And out of that 600, 500 milliliters will be reabsorbed because of this mixing segmentation contraction. Okay? So that's what happens. Then another important motility, type of motility in this large intestine is called mass movement. Okay, now why is it called by this name? It's called mass movement because of the force and the volume of fecal content that moves. And the purpose is to do what? Now, when in part 4 of this lecture, we're going to talk about some special types of gastrointestinal reflexes. But let me just mention it here. When you eat food, especially in the morning, breakfast, when you take in fresh food, okay, what happens is that there is usually a reflex reaction that transfers from the stomach to the large intestine to tell you that new food has arrived or new food is about to arrive. So it happens most times just before breakfast. Okay? It happens just before breakfast or just after breakfast. Okay? So the purpose is to make way for new content. All right? Because if it happens that your large intestine is still full of fecal content, undigested food, it will affect the rest because they are all connected, all the different parts, they respond to each other. When we talk about the reflexes, you will see that what happens here affects, in gastric emptying, we talk about enterogastric reflex. What enters the small intestine inhibits further emptying. So they all affect each other. So if fecal content does not move away, it will affect further peristalsis in the upper parts. So that's what happens. It has already known that this breakfast is about to come or breakfast has just arrived. Let's create space. So that's mass movement. It's a massive movement of fecal content in the large intestine. It usually leads to defecation. Most people have this, what they call bowel habit. Of in the morning, they defecate. It's as a result of this mass movement. Okay? So one of the things you can learn from that is that when you wake up early in the morning, it's good that you take water. The purpose of that water is to stimulate this mass movement. And you call it gastrocolic reflex. Okay? Something enters the stomach and it stimulates the colic, to bring about this mass movement and you now go to toilet and defecate. All right? So that is what happens in the large intestine. So in the part 4, we're going to be seeing some of these reflexes and what happens when you defecate. Okay? Defecation is another very major motility function of the GIT. We're going to look at that. So I've written a few books on physiology, on gastrointestinal physiology, said gastrointestinal physiology broken down for you. Okay, and some other books, about 6, 7 of them, right? So you can check the description box and click the link to download just for a token. It takes you to Okada Books, download it. Also check out our website. The link is also there. So you can see some other things we're doing to make the learning of physiology easy, exciting, and effective. So see you in the next video.